Hey everybody, I hope you've been enjoying digital film lighting so far. Um, I wanted to take a few minutes and talk to you folks about a few things, some new tools that you might have been encountering in some of your reading. Um, so far, I hope anyway, that you've been finding the readings interesting, helpful, and informative. And I'm hoping that some of the discussion posts are going to start generating some interesting conversation about some of the topics that we've been researching and exploring in your tutorials and in your lesson assignments. Um, so, so let's take stock of where we're at. Um, we've been talking about, we had an initial conversation about uh, basic electricity. I think any film lighting class should start there. We need to understand the fundamentals of how we make our lights go before we can do anything creative with them. But moving on from there, we're now starting to have discussions about the quality of the lighting that we're doing for our film and video assignments, and the type of lighting you'll be doing out in the field once you become a professional and you're doing this, on a daily or weekly basis. Um, so we're talking about shape, we're talking about color, we're talking about directionality, we're talking about whether a light is hard, generating a lot of deep, stark shadows with very definitive umbras or shadow lines. We're talking about softness and the diffused quality of some of our light. Does it render gentle umbras on the face of our subject so that the shadows blend delicately from highlight to shadow with a very subtle transition? Um, we're talking about the color quality of those lights. Is it warm, like tungsten interior lighting? Is it daylight balanced or whiter in appearance, like our outdoor or daylight balanced fixtures? Um, and we're talking about mood, and we're talking about how the lighting can serve a story. Um, but up to this point, we really haven't had a discussion yet about how we measure the light. Now, in your initial digital imaging class, I believe you discussed basic exposure, creating a good balanced exposure with your Sony camera in still photographic mode. And you probably talked about the histogram function at some point in that class. And so you should have some sense that there's something mathematical going on inside the camera. There's a balance of how much light is coming through the lens of my camera, in what time frame. We may or may not be fully comfortable with what that transaction is that's happening inside the camera. But there is a way to measure what we're doing. Okay, if you had to add a large column of numbers for your math homework assignment, you might use a calculator. If you wanted to take the temperature of the ambient temperature in your living room, you might use a thermometer. You want to take the temperature when you're sick, you might use a thermometer. Um, when we want to know how much light is available in an environment that we're going to shoot in, or how much light is coming out of a fixture that we're using to create the exposure for the video that we're shooting, we have a tool for that. It's called a light meter, and I want to talk to you about light meters a little bit today. So if you'll just lend me your ear for a few minutes, I want to give you a little background on how light meters work, what information they give us, how we can apply it to the camera, what does it all mean in terms of our exposure and in terms of how we go about lighting our shots for our client. Not too long ago, we had a discussion about where to start thinking about the quality of light, where we determine the best placement for our lights, what information are we using to arrive at those decisions. And we talked a little bit about classical art, and we looked at some examples of some pretty neat stuff from the Renaissance painters. Remember Rembrandt, for instance, the guy that gave us the golden triangle and the dramatic side lighting that he was doing for the majority of his work. We may have had a discussion about chiaroscuro, and the word chiaroscuro, that means the nature of the contrast of an image that we're creating, the relationship between highlight and shadow, and how great that ratio may be, how wide that ratio may be between highlight and shadow. That whole method of thinking about the relationship between highlight and shadow describes the nature or the chiaroscuro of an image that we are looking at or creating. So let's do a little mental exercise for a moment. Try to imagine for a moment what it would be like if, when you had to light a shot for a video, all you had was one of these. All right. It's a wax candle. And in the days of Leonardo and Rembrandt and Michelangelo, Vermeer, Leonardo da Vinci, some of these amazing individuals who are doing some of this beautiful work, Peter Paul Rubens, Matthias Stomer. What we're talking about is this. We're talking about candlelight. And we're thinking about it in terms of it being a light source. Now, what do you think it would be like if every time you wanted to take a picture, you had to organize a whole bunch of these? Well, what you may or may not realize is that every time you're using a lighting instrument, you are basically organizing a whole bunch of these. And I'm going to tell you how that is. I love that. Do you remember when I showed you this guy? This was from Matthias Stomer, 1633, and it was called The Mocking of Christ. Now, this is what we got going on in that image, right? We got a candle, and we got some central characters, and we have one main character who is getting the bulk of the illumination. And the candle is located in the middle of everybody, right? So we talked a little bit in that discussion about this image is the basis for how a light meter is figuring out how much light we have to work with so that we can adjust our camera properly. Okay? Now, we have a few different kinds of light meters, and basically what they do is they measure the number of these present in a volume of space. Okay? And they are using a unit of measure that we call a foot candle. Okay? So we'll have a meter designed to see how much of this is going on in our shot, right? So we'll basically take our meter, and we have, on every light meter, we have a diffuser Okay, and we want to orient that diffuser in a couple of different ways. Now, a lot of the textbooks will tell you, take your diffuser, walk out in front of your talent or your subject, and aim the diffuser at the camera. Okay? Well, that's fine from a certain point of view. Okay? If we want to know just how much light is happening inside a room, what I want to do is I want to take this diffuser and I want to orient it towards the bulk of what's hitting me. In this case, it's my key light that's bouncing off of the wall over my desk. Okay, so I'm going to take a reading of that, and my meter's going to tell me it's about 60 foot candles, more or less. Yeah, about 60 foot candles. Okay, now this particular meter turns on and off, but you can see there's a little digital readout in there. And this is active, so it's telling me constantly as I move this meter around how many foot candles are in the little window. And then I have to do a mathematical calculation to translate that into a number that I can use on my camera lens so that I can create a good exposure. Now you've got a little tool inside your Sony video camera called the histogram, and the histogram, when you turn that on, you see a little waveform in the viewfinder or on your little 3.5-inch LCD screen. You see a little waveform, and that's representative of the overall exposure across the entire composition, and it gives you peaks and valleys that represent values of highlight and shadow exposure. Okay, and that's good because it gives you an overall picture of what the foot candle allocation or arrangement within that scene might happen to be. So a meter that reads foot candles gives us basically an idea of the presence of how many of these in a volume of space that we're doing our capture. Remember, this isn't exactly 12 inches, but one 12-inch taper will render a candle flame about 1 inch high. So a 1-inch candle flame within 1 cubic foot volume of space. So imagine a box and all 6 sides are 1 foot square, right? About the size of my head, right? 1 foot candle in that amount of space, okay? And this meter will tell us how many of those units, for instance, might be in the room behind me, okay? Now, according to Kodak, who used to be the purveyor of all of the photographic wisdom in terms of film and processes and so forth and exposure, used to tell us that for the standard ASA, American Standards Association, or currently ISO, International Standards Organization, ISO 500, in order to get a usable image out of a scene, you had to have at least 4 foot candles, 4 of these present in that volume of space around your subject. Okay. Now, if your subject is the entire room, then you need a minimum of 4 foot candles and probably more to light up an entire room, all the walls and so forth, and see what's inside. If you just want to get a proper rendering of me in that room and you're framing me up kind of like what we have here, you need at least 4 of these illuminating my face in order to get a usable exposure out of ISO 500. Okay, so with ISO 800, we might be talking about 3 foot candles. Okay, doesn't seem like a lot of light, does it? If you remember Matthias, he showed us basically how much illumination we could get out of one 12-inch taper. And he's taken a little bit of creative license because that flame looks a little bit higher than 1 inch. But you get the idea. Okay. So foot candles, and you can see on this one, I've had this meter for a number of years. So I've made myself a little cheat sheet Some of those numbers might look familiar to you. 2, 8, 4, 5, 6, 8, 11. Those are the numbers on your lens on your video camera. Now if you look down here, you'll see 32, 69, 128, 256. Those are foot candles. Okay. Now if you look way down here at the end of the scale, and this is really hard to see, I have a 1-4 is 8 foot candles. Okay. So that means 4 foot candles was going to be about an f 1.2. You guys don't have 1.2 on your lenses. That would be a lens that was probably this big around with a lot of light gathering capability for shooting in low light situations. Your lens, I think, starts at around a 3.5. Very quickly, it closes down to a 4. By the time you get to the other end of your zoom lens, I think you're at a 5.6 or an 8. But basically, I had to make myself a little cheat sheet with foot candles and their corresponding F numbers. So when I pushed the button here and I took a reading and I got an indication of, what's that say, 25, 26, 27, 27 and a half foot candles. I see my closest is 32. So that's getting me about 1/3 of a stop under a 2.8. A light 2.8 we call it on the lens. If our minimum f-stop on the lens was a 4, call it in round numbers 30 foot candles. Okay, if I need 30 foot candles for a 2.8 and my lens is a minimum of a 4, that means I need 60 foot candles for a basic exposure at f4 on my Sony lens. If I was only getting 30 in that situation, my shot would be 1 stop underexposed. Okay? You're going to remember as you read and do your research how these numbers relate to one another. You were kind of introduced to it in your digital imaging class. We're talking about it a little bit here. We're going to talk about this a bunch more times in the course of Lighting 1 and Lighting 2. Okay? Now, moving forward, not a lot of people want to work with the foot candle meter because it's a bit of mental math. And in the early days of photography and cinematography, foot candle meters were pretty much all anybody had. So if you were doing this for a living, you really had to be comfortable using the foot candle meter. When I first started gaffing professionally, and I was working with directors of photography who had been in the industry for a while, some of those guys only knew how to talk in terms of foot candles. So if I wanted to do lighting for those people, I had to know how to use a foot candle meter, and I had to know how to make those translations in my mind on set while we were setting and shaping lighting, so I could talk to the cameraman and give him some idea. Yes, sir, we have 30 foot candles over here. You said you wanted to shoot at a 2.8. We have 30 foot candles over here, and that is a light 2.8 by my meter. Okay, and then maybe the DP would go over with his own meter and check to verify those results and see if we concur. If not, one of us had to adjust our meter, or we would make note of the difference, and every time a measurement took place, I would consider the difference and add that to my meter reading so that I was telling him by his meter what the available light was. Well, now, thanks to companies like Minolta and Sekonic, Chiaroscuro, which used to be Konica, which used to be Minolta, makes light meters for us that take some of that arithmetic out of no pun intended, out of the equation for us. So here's a light meter today as we use them on sets. This happens to be a Minolta Autometer 4, I think it is. Yeah, 4. And so you can see I have a shutter speed here, which in terms of video is going to correspond to a certain frame rate. Now, you may know by now, if not, you'll learn in this in cinematography class, that at 24 frames a second, which is the standard persistence of vision for motion picture presentation, 24 frames a second. Okay, 24 frames per second corresponds to a camera shutter speed, and it just so happens that that shutter speed is 1/48th of a second. Now, I don't know why Minolta chose 45, except to say that in and around 45, we have a couple of other speeds. We have a half second, which is represented by 30, or 1/30, and we have a quarter of a second, which was represented by 1/15. Okay, so I suspect that 1/30 and 1/15 is 1/45, if my math serves me, and so that's probably why Minolta opted for 1/45. But what we know about 1/45 is that 24 frames per second is actually 1/48th. So 1/45 is going to be something around 18, 20 frames per second. Close enough. The light meter is going to give us, for 24 frames per second at 800 ISO, which is the native ISO of your camera in compressed mode, it's going to give us an F number right here when we activate the button. You see that? F4.4, 4.04, excuse me. That's an F4 and 4/10. That's the exposure value of the light hitting my meter right here off of my key light that's bouncing off the wall. Now, when I take that reading, I just point the diffuser in the direction of the light source, and then I check it out. There we go, 4.5. Okay, so on my lens, or in your case, you're going to hit your scroll buttons on your button control panel, and you're going to scroll from a 4 to a 5/6, and then you're going to realize that you can stop halfway in between. You can go to a 4.5 or 4.05, which is a F4 and 5/10. Okay, and if you had this much light on your subject and you were shooting with video and you didn't have the benefit of your histogram, this meter would tell you how to set the lens on your camera. That's really all that's going on here. It doesn't have to be any more complicated than that for you guys at this stage in your lighting experience, and I don't want to overwhelm you with a lot of extra information about what this is really doing. But basically, a meter like this is trying to consider, depending on where I point it, like I can point this meter off to my shadow side and take a reading, and the number is going to be a lot different than the number I got when I pointed it at my key light bouncing off the wall. It's about half as much, and the reason why is because that key light's bouncing off the wall here, it's reflecting over there, bouncing off that wall, and it's giving me just a little bit of something happening over here on the shadow side, but not nearly as much as what's coming from over here. What this meter is going to do is it's going to take all that information into consideration, and it's going to average it all out, and it's going to give me an F number that represents a pretty fair estimate of proper exposure when I set the lens to that information in the readout. Okay, so that's what a light meter is doing. Okay, now if you point it directly at the camera and you consider equally how much shadow is on this side and how much highlight is on this side, I'm going to get a meter reading that is somewhere in between the F2 from over here that we just read and the F4.5 over here from the key light. And it just so happens that that answer is a 2/8 and 7/10. Okay, so that's about a third of a stop different from the reading I got off the wall and the reading I got on my shadow side. And what you need to understand is that that's something like an average between the two extremes. And that's basically the idea between taking an average reading and taking a point source reading of a light value to determine how to set the camera. Okay, so do I want to set the camera in such a way that I expose for the overall sense of what's happening here. That's what your histogram is doing when you use the histogram to set your camera. You'll notice sometimes when you adjust the histogram and you're adjusting the iris on your lens, you do it in such a way so that the peaks and valleys settle into positions that you know to be acceptable for an exposure, right? Not too high and not too low, right? And then you look at the image and you say, well, you know, it still looks a little washed out. It looks like still a little bright. And if you close down the lens a little bit more, say from a 4 to a 5.6, right, the image gets a little bit darker. The highlight peak will come a little bit lower, and the shadow peak will get a little bit lower, right? Your exposure went down because you closed down the iris in the lens a little bit, okay, to make the image a little bit darker, which looked a little bit better to your eye. The colors were more saturated. There was detail in the highlights that was lost when you had the lens open to a 4. You get a little bit of that detail back in the highlights, and you get an overall image that you're more comfortable with, that you feel represents the trueness of what's in front of you to your eye, right? That's the beauty of HD and 4K cinematography at this point. We know that information right away by looking at the monitor on our camera or the inspection monitor that we have set up for the director to watch the program as we shoot it. We can go over to those monitors, look at the work that we're doing, evaluate the results that we see on the monitor, and if we want to make adjustments, we can make those adjustments on the fly, knowing that information electronically. That's something we couldn't do when we were shooting film. So that's what we're doing now, okay? So we went from a foot candle meter to, this is called an incident meter, okay? Because I can take an average reading here to camera, or I can measure my light source and only consider what's hitting from the source, right? I can do it a couple of different ways. That's called incidence. Incidence refers to, it's really the idea of reflection values, okay? When you're talking about light, light emanates from a light source in a vector or a direction. It bounces off a surface and it reflects on something and we see it, right? So the incidence is the angle that's formed as the light hits a surface and reflects off. That angle is called an incident angle, right? So an incident meter is measuring the light somewhere between the source and the surface that it's hitting. Somewhere in between those 2 points, this meter can be applied to figure out how much light is there. A reflected meter, like this one, measures the light that has already reached its destination. The subject that we're photographing, the light bouncing off my face, can be measured with a reflected meter. In this case, this is called a spot meter. And if you see, it has a lens on the front and it has a viewfinder in the back, okay? So the idea is you put your eye up to this guy and you measure a value like the light hitting the wall. That's my key light. And lo and behold, it gives me exposure information in the little liquid crystal readout, just like this guy was doing, right? It's giving me the same kind of information. The difference is, instead of me intercepting the light somewhere between the source and the subject and figuring out, oh, how much is there and which way do I point it and so forth, this one, you just look through and you point it at your subject, you click the button, and you take the reflected reading right off the surface of your subject's face. Now this is telling me a 5/6 and 2/10. Remember how this one was only telling me a 4.5 or a 4 5/10? There's a little bit of difference between the way these two meters interpret that light. Okay, so learn to trust this or learn to trust this, and then stay consistent with the way you read the available light, if, remember, we were talking about how you looked at your histogram and at a 4 5/10, the image looked a little bit bright, and you thought if you closed it down to a 5/6, it looked nicer. And then this one told us a 5/6 2/10. This one sees the light the way you see the light, okay, the way your eye perceives it. And it gives you an overall reading that represents something we call 18% gray. And 18% gray, Kodak, like I mentioned to you before, the last bastion of all wisdom and knowledge concerning exposure, film stocks, and capture devices, used to produce a thing called a gray card. I have a small one in here, which will be a nice demonstration. A gray card was something like this guy right here. And if I were to hold this out in the set, right? If I were to hold this out into the set and then I were to take a meter reading off of it with my light meter, it would give me a light reading, okay? I read the one off the monitor and it's telling me an 8, F8 at a 40th of a second. That's a pretty conservative judgment on this gray card. The idea is the difference between an absolute black value and an absolute white value in any scene that we're photographing. The average of those two exposures is gray, medium gray, okay? And medium gray is supposed to be roughly the same contrast or gamma of skin tone. You can see that it's a little off, okay? So you have to take this stuff with a grain of salt when you use these kinds of tools. You have to do some testing prior to trusting these things to calculate your final exposures. Now, with film, when we didn't know what our images looked like until after the negatives came back from the developer and we had prints to view to see if we got our exposures correctly, this stuff was really important to us. But nowadays, we have digital video and we have monitors, and so we can go to a monitor, and as long as that monitor has been adjusted properly, the image we see on that monitor is pretty close, if not exactly what we are capturing in camera on our recording media, okay? So bear in mind that whatever tools you elect to use, whether it's the histogram in your camera or an incident meter or a reflected meter, okay, learn the particular nuances of how that measuring device works, and then do some tests so that you make sure that when you get a reading out of either of these tools, that the reading that you're getting is that you can visualize that reading, or you can see the results of that reading on the monitor and become familiar with what those things look like. Okay, it seems a little bit maybe like I'm speaking in generalized terms. That's kind of true. You guys haven't had that much experience with this stuff yet, so I can't be real specific. But the point is, pick one of those kinds of meters, learn how to use it properly, and learn how to gauge or expect the typical results that you're going to get by using that tool as a reference for measuring your light. Okay. There's two other types of meters I wanted to talk to you about, and they are technically light meters, but they don't give us exposure information. They give us color information, and they're called color meters. This one is the Minolta color meter. It's a few years old by now. I'm sure there's a newer model that looks a little spiffier than this, but basically they all work the same. Where this one tells us how much light is present and how to set the f-stops on our lens, this one just tells us what color the light is and how to correct it if we want a different color result. Now, the two types of color that we talk about the most in photography and videography and filmmaking is tungsten and daylight, and the color qualities of each of those. Now, daylight obviously is the quality of light that we perceive when we're outside at noon on a semi or cloudless day, that color quality is what we consider daylight, and it has a value assigned to it in Kelvin degrees of 5,600 degrees on the Kelvin temperature scale. Lighting inside, incandescent lighting, like from a regular light bulb that you'd have in a lamp on the end table in your living room next to the couch, or over the stove in the kitchen, or in the reading lamp next to your bed, okay, incandescent light sources run at a Kelvin temperature of about 3,200 degrees on the Kelvin temperature scale. And a meter like this will tell us where in between those two results our light source is falling, okay? So if we set our camera to a sensitivity that it sees 3,200 Kelvin light sources as white light, okay, not orangey and not blue, but just white light, the way we kind of perceive the image on my Mac cam right now, okay, then we want to use light sources that emanate 3,200 Kelvin. The camera is set for 3,200 Kelvin, and we want to check the output with a color meter to make sure that we're at least very close, if not spot on, that particular value, so that our images don't look tainted or tinted in one way too blue or another way too orange looking. Did you ever take, well, maybe you've used Kodak or Fuji disposable film cameras and maybe you haven't, but once upon a time, if you had a disposable film camera that you had to take to the Walgreens or the CVS pharmacy to get developed, and you took a picture in your living room in the evening with the house lights on, your images came back, and unless you used a flash, your images came back very orange in color, okay? That's because the film had a sensitivity closer to daylight saturation than incandescent saturation. So it was balanced for 5,600 degrees on the Kelvin temperature scale, and you lit everything with house lights, which are orange in color when seen with a 5,600 Kelvin capture device, or in this case, a daylight disposable film camera. So the same problem can arise with your video camera if you have it set one way or the other, okay? You have a couple of hard presets on your video camera for 3,200 Kelvin and 5,600 Kelvin. That's your indoor or incandescent color setting, 32, and your outdoor color setting, which is the same color as this LED right here, 5,600 Kelvin, okay, for outdoor lighting and exposure. Okay, and if you have the camera set in the wrong position and then you go under the opposite light source, you're going to see the light looking too orange or too blue. Okay, so you flip the switch on your camera and voila, all of a sudden everything's back to white. You can also do something called white balancing, which we'll talk about a little bit later in lighting too, for instance, or in cinematography. And you can tell the camera to balance to white whatever color light it sees at the time you're taking pictures. That's a different story altogether. If I just want to know, for instance, out of my key light here, how much or what color quality that is, I can use a color meter and I can get, you see a value in there. Oops, I need to be on Kelvin. Okay, 4350. Okay. Now, 4350 is somewhere between 3,200 and 5,600, right? So what does that mean? Well, I have a daylight balanced fixture, but as you can see behind me, the walls in this room are like a natural, very light beige, or I think they call it an eggshell, or a dark eggshell color. Okay, so that color is kind of warm. Now, there's a basic principle of physics, and notably in photography. Any light source that you shine into a situation, if you bounce that light off of a surface, the resulting or incident value that reflects off that surface will acquire the color quality of the surface the light bounced off of, okay? So if I have a white light and I bounce that light off of a blue card, the resulting reflection is going to have a blue color cast to it. Well, in this case, with my key light, my 5600 Kelvin light source bounced off a wall that had a warm color cast to it. So the resulting color hitting me is now not 5600 Kelvin, but it's also not 3200 Kelvin, which is what that lamp is behind me. That's really orange, and I only look somewhat warm from the 4350 degrees of Kelvin temperature that's falling on me now. Okay, this kind of meter is what tells us all that information, lets us know. Now, let's say, for instance, I felt like this was too fleshy. My skin looked a little bit too brown or too warm, we call it. I might put some more blue gel on that light so that after it bounces off that warm colored wall and hits me, it has a whiter appearance. Okay, I'm constantly correcting or adjusting or balancing for values within the frame, whether it's the exposure and the amount of light that's hitting me, the hard or softness of the quality of light that's hitting me, or the color of the light that's hitting me. Okay, and all of those values, if you'll remember from your 3-point lighting reading you've been doing, all three of those factors, okay, three if I'm in a Tarantino movie, all three of those factors are aspects of what light in our 3-point lighting scenario. Boo, 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 doo, 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 doo. The key light, right? Remember that from your reading? The key light gives us the shape of our subject, the overall exposure that we render to camera, and it helps to establish the color quality of this going on within the frame that we're shooting. Okay, so a light meter tells us how to set the camera. Color meter tells us how to balance the color quality of the lighting that we're using. Okay, we use a couple of these types of tools in conjunction with a very powerful platform like the Sony FS700 camera, and you have, together with your working knowledge of videography and filmmaking, a pretty effective combination. Okay, one last light meter I want to show you, and this one's my favorite. This one is called a spectrum meter, and this is a handheld spectrum meter. And up until a few years ago, this was a physical near impossibility. And through the miracle of science, they have now made it to fit in the palm of my hand, just like my cell phone. They need an app for that. I'm going to turn this guy on. The thing of it is this thing is more like a computer than it is a light meter because it tells me a lot of stuff. This particular meter is made by a company called UPR, and it's the UPR Tech 350 spectrum meter. And what it's going to tell me are a few basic pieces of information, which you maybe look kind of blown out on the monitor, but you can see it's going to show me a spectrum relationship. That's a physical graph that shows me the color quality of my light output. It's going to give me a basic set of exposure values. It's going to give me a CRI or a CIE 1931 and 1976, which are color indexing exposure values that give us some idea of where within the spectrum from between red or infrared and ultraviolet, where the actual physical white point is of the source. And that's a mathematical thing. They use it for making television sets. They use it for the programming of light meters. They use it for standardizing the manufacture of LED chips and so forth. But if I wanted to know exactly what the color quality of this value was, in other words, my daylight source bouncing off a warm colored wall and hitting me now for my Apple camera, I could take this meter and I could select spectrum output, and then I just hit the actuator button on the side, wait for the beep, And voila, it tells me in a graph that looks a lot like the histogram in your camera, it tells me what the output color quality of that fixture is. Now, if I was a manufacturer making lights for the film industry, I'd need to know this information. If I was working for the network, televising the football game, I'd want to know this information. If I was working on a major feature film and I was shooting in a location where I had to use available lighting, like in a football stadium or in a museum, or in any public place where I couldn't affect or change the quality of the light that was already there, I could use this information to then adjust my camera to properly function in that environment without seeing a color shift. Okay, so there's a lot of reasons why I would want to know this information. When you're purchasing lighting equipment, you might want to know the quality of the output of the fixtures you're buying so that you can begin to understand the quality of light that's going to come out of that device. Okay, for instance, an LED fixture, I would want to know, does the LED have a complete full spectrum output, or is it missing some of the color values present in a normal visible photographic spectrum? If it is, I know that that light source is not a full spectrum light source, and it's probably not going to render flesh tones very well. Things are going to come out looking brown or too red, or have a green cast to them, depending on how imperfect the spectrum is of the light source. So when you're talking about high intensity discharge lamps, hydrangea metal medium arc diode lamps, HMIs, or LEDs, you might use a spectrum when you go to LDI or National Association of Broadcasters Convention, NAB, where they show the new gear every year for the film and video industry. You might take a meter like that and test the equipment that's for sale to make sure that the color output is what you want. It's another way of knowing something that seems unknowable, which is the ambient quality and volume and color of the light that surrounds us or the light that we're using to illuminate our subjects. Okay, so light meters are very cool tools that professionals use to figure out how much of something we have, what color it is, and how we need to set our camera so that the result we get on the monitor is the result we're looking for, the result that suits the story, and it is the quality of image that the director and the director of photography planned for or anticipated in their pre-production discussions before getting to location and shooting. All of this is the thought process that goes into professional filmmaking, professional videography, and I just wanted to give you guys a basic sense of what it is that we're doing in layman's terms. I hope it wasn't too confusing. And just remember, it all started with one of these and some folks that were paying really close attention to how this affects this. And that's all I have for you. Until our next face chat, thanks for tuning in. Thanks for giving me a moment of time to let me explain this stuff to you. And as always, if you have questions about what I've discussed, or if you just want to talk further about the concepts that I've tried to go over for you here in the last few minutes, you can email me. You can use my office phone. You can send me an email in the LMS. I will get back to you. I want to hear from you. I want to answer your questions. I want to make you a more effective and creative lighting filmmaker. So have a good day. Enjoy the class, and I'll see you again back here real soon. Thanks a lot.